Trigonometry, Chapter 2, Acute Angles and Right Triangles. Section 1, Trigonometric Functions of Acute Angles. Video 8, Special Angles, 30 degrees and 60 degrees. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. All right. In the previous video, we learned about the 45-45-90 triangle and calculated all trig functions of 45 degrees. In this video, we derive the trig values for two more specific angles, 30 degrees and 60 degrees. In order to derive the values of trig functions of 30 degrees and 60 degrees, we need right triangles that include those angles, plural. However, since these angles are complements, they exist in the same triangle. So we only need one triangle. This one with a 30-degree angle and a 60-degree angle. It doesn't have to be oriented this way, but it looks like this or that, depending upon how the video is showing. Next, we have to assign lengths to the three sides. Not doing very good with typing today. These lengths must have the correct proportions. Now, we are free to assign any one side a length, but which one? And when we do, how do we find the others? Well, there's a standard trick for calculating a correct set of lengths here, and that trick is to embed this triangle into an equilateral triangle. This is achieved by taking a reflection of this triangle across its longer leg. In other words, let's scoot this triangle over and take a mirror image copy of it like this. And if you'll notice, this is an equilateral triangle because all of its angles measure 60 degrees. The one on the top is 30 degrees twice, and this is literally a mirror image, which is why the numbers are backwards. Now, because it's an equilateral triangle, all three sides are congruent. We are free to assign any length to all three sides. So we're going to assign a length of 2 in anticipation of it being split in half on the bottom of the triangle. 2 on the left, 2 on the right, and split in half, 1 and 1 on the bottom. Now we go back to the original 30, 60, 90 triangle like this and realize that we're only missing one side. The Pythagorean theorem will get us the length of the longer leg, and there are all the details. Not going to go through it because it's just a baby Pythagorean theorem problem. The longer leg is the square root of 3. And there we have it, our 30, 60, 90 triangle. Now that we have a 30, 60, 90 triangle with side lengths, we can easily calculate the trig functions of both 30 degrees and 60 degrees. Just remember, adjacent and opposite is relative to the angle you're using. For 60 degrees, the adjacent side is 1 and the opposite side is the square root of 3. Since the hypotenuse is 2, the trig function values for 60 degrees are, here's the definitions. Remember, we're looking at 60 degrees. Adjacent is 1, opposite is square root of 3. Hypotenuse is 2, and it gives us these. 2 of which can be simplified, 2 of which can have rationalized denominators. Tangent and secant can be simplified, they're over 1. Cosecant and cotangent have denominators that can be rationalized, and we end up getting this set of values. Now either memorize these or memorize the triangles and use the definitions to determine these values. Should have said triangle singular. Personally, I memorized everything. Now, as for 30 degrees up here, we could do the same thing, only this time we'll be using an adjacent side of the square root of 3 and an opposite side of 2 while still using an opposite side of 1 while still using a hypotenuse of 2. Or we can use cofunction identities. For each function below, we can replace the function with its cofunction and the angle with its complement, which happens to be 30 degrees. I think I'm going to choose to do that. So yeah, you can reconstruct all of the definitions with the 30 degrees, or for each one of these, change it to its cofunction, change it to its complement of 30 degrees, and it ends up looking like that. For example, change sine to cosine, change 60 to 30, same value. Change tangent to cotangent, change 60 to 30, same value. So we get the same values just in different trig functions because of the cofunction identities. Now, regardless of how you derive them, you need to be able to get these values, either memorize them all, including the 6 we saw for the other triangle, or use the triangle or triangles to build them. If you memorize them, they're faster, but it's easier to just build them from the triangles, in my opinion. Now you try. Pause the video and try the following. Calculate the following trig values. Notice I stuck a 45-degree angle in there. All right, here's your fair warning. Solutions in 3, 2, 1. And I cannot stress this enough. Either memorize the values or memorize these triangles and use them to calculate the trig values. They are not going away as long as you take trig and beyond.